You are given a coordinate plane, right? I know I'm about to get out of the way. I don't like it when I don't have my remote. Alright, so I have two dots. One dot has the coordinate of x1, y1. The other dot has the coordinates of x2, y2. Okay? Now, everybody should know the shortest distance between any two points is one straight line. We understand that, right? So in order to find the shortest distance, I would draw one straight line from the coordinate y1, x1, x1, y1 to x2, y2. Okay? So I would draw that type of line right there. Alright, so therefore you have distance. Okay? Now, all the distance formula is doing is adding up how much movement you did on the x-axis and how much movement you did on the y-axis, putting them together and then doing the square root. So, this red distance right here, that's your x2 distance. Does everyone see how that's your x2 distance? It's going from 0 to where's your x2? Everyone see that?
Oh, so x2 would be like to like where the
it's from 0
where they meet up
all the way to x2. Yeah. So if I drew a line from this dot straight down, that's my second x, right? That'd be my x, my number. Okay? Everyone with me? So this red distance is that distance between the y-axis, which is 0, and to get to the second x. Alright, so you have the distance of x2. Now, this distance from 0 to this point would be the distance of what?
X1?
X1. Very good, Marvel. So from here to here, that's my distance of x. Anytime you're moving horizontally, you're checking the distance of your x. Okay, horizontal movement is your x. So, as you see, this is your distance from x1, right? So therefore, if I subtract out x1, subtract out x1 from x2, I'm left with this blue arrow right here, right? Right? We do understand that, right? Yeah. Therefore, this blue arrow is represented by x2 minus x1. Okay? So that is how we get this bottom distance, all right? Now remember the Pythagorean theorem because it's going to come into play. So now this up and down distance is giving me the distance of what?
Y2.
Y2. Does everyone see that? Devon, it's not in your necklace. All right? Does everyone see how this is Y2? We're sure? Positive?
No.
Who said no?
Bonita.
Sweetie, where's Y2?
All right.
Down to 0. Okay? We good?
I didn't want to make it. Chill out.
All right. So now what's this short distance showing me? Y1. Okay?
Yeah.
So therefore, if I subtract out Y1 from Y2, what am I left with? Exactly. That little blue line that shows me Y2 minus Y1. You guys see that? So now, huh? X2 minus X1. All this right now is doing is showing you guys how the Pythagorean theorem comes into play. Alright? This makes one right triangle, right? Right or not right?
Right.
Yeah.
So if that makes one right triangle, I should be able to solve this distance D, right? By the Pythagorean theorem, right? So in this case, what's my A? What's my A?
Y will find x1, find x.
Close. You're very close.
X squared minus x1.
Looking at this, and I know this is a right triangle, my A and my B are always my two legs, right? A, B, or B, or A, B, however you want to name it, right? You got that?
Isn't it true, like, since that's a right triangle, like, don't you like put a little box on the?
Yeah, you can. Yeah, you can. But since we're in coordinates, I'm not going to draw a box in it.
Yo, one teacher told me it don't matter which side.
It doesn't.
Be wrong.
It doesn't.
Alright, so.
If someone would have said A was Y2 minus Y1, I would have took it, but no one did.
Alright.
Alright? Everyone heard her say that? Your legs, it doesn't matter which one you choose to name A or which one you choose to name B. But you need to make sure it's your legs I can't name D, A, or B. Okay? So in this case, since Devon told me x2 minus x1 is A, I'm going to hit that up. I'm going to do x2 minus x1, that's A, right? But what do I got to do to it? I got to square. That's A, what's B? By the raising of our hands, we're going to answer this question. Fatima.
Y2 minus
Y2 minus Y1.
Square.
Square. In this case, by the raising of our hands, question, Eric. D. That B.
Square.
Bam, I have the Pythagorean theorem.